All right, thank you everybody for coming here and being curious about the journey we took on how to automate the inbound process, specifically truck unloading and then making the pallets. I'd like to begin the talk today with what it is we're experiencing in today's days and age. Um, Basically, demand is increasing exponentially, 4 to 5% every year, and a lot of imports, a lot of local goods, and everything gets transported across distribution centers and across warehouses in containers. And currently, there is no system right now that can automate that. And actually, if you also take a look at the data, the labor participation rate is decreasing. So every year, people want to do this type of job less and less, right? So what do we do as an economy? How do we continue to grow, right? You were sort of forced to automate just because there's no other choice. So this is what the traditional warehouse looks like for a lot of you guys. And as you can see, we have the inbound dock, and there's usually forklifts or truck unloaders that people that are taking things out of the truck, putting them into pallets. Later on, they go into storage. And finally, you have the outbound process, which is mixing things up so they can go to other distribution centers or stores or whatnot. However, the problem really is, in this entire process, the loading dock, right? If you think about it, only one case is coming out at a time, right? There's usually one person in there. It's very rare to see more than one person in there. And so that sort of determines the entire throughput of your warehouse. How fast can you take things out of a truck? And one of the benefits of automation is, one, we can start increasing that throughput. Two, we actually see reduced costs, right? Because now you don't have to worry about people getting hurt or training people correctly. And you get a lot more traceability in terms of what is getting out of the container and going into your warehouse. Everything becomes more trackable. However, it is a big challenge to automate this unloading process, especially with robots. One of the reasons is because the operating space is small. So typically, this is what a robot system looks like. And this is a traditional palletizer or depalletizer. And it's huge, right? A person maybe is as high as like that gray pillar that the robot is on, right? And then that's just doing work on one pallet at a time, right? And the robot needs to be this big because it has to do a full 8 feet of the pallet, right? But in trucks, this is your operating space here, right? It is very, very, very small. We actually don't have technology today to try to figure out how to get our machines in there to automate the process. Right, so that is challenge number one. Challenge number two is the variety is huge. I'm sure all of you have seen what the inside of a truck looks like, and it can be anything, and the box can be in any type of orientation. So how do we get an automation system to go and solve this problem for us and at the same time deliver value to end users that are putting the stuff in their warehouses? But before that, I'd like to tell you about who Mujin is. I'm sure that many of you have not heard of our company before. We were founded 12 years ago in Japan, and very recently, in the past 2 years, we created offices here in the US to start putting all of this automation technology that we've worked in the Japanese and Asian market, start putting it in the US market. And one of the key things about this technology is the Mujin controller, which is the intelligent robotics platform of the future. Basically, if any of you have tried to integrate robots or other automation systems yourselves, you will know how tough it is to combine all the different control systems, all the different sensors, all the different conveyors. Maybe you have vision systems, et cetera, et cetera. With the product we've developed here at Mujin, you just need one system, and that is the Mujin controller. And you can connect everything else to that. And the way you use it is by specifying, models and constraints in your task. There's no programming here in this system. Well, what happens if, what happens if we get a new application? With this Mujin controller, we actually, it's pretty easy. And here's what the flow looks like. So we first build a digital twin. And from the digital twin, then we can start doing the real-time robotics control. We have real-time integrated vision inside of that, which goes into motion planning. And then that feeds back into the digital twin. So this cycle is what we call machine intelligence. And this is what every single industrial robot in the next 10 years is going to be using, guaranteed, to do intelligent motion. The days of programming robots are gone. Now, what happens if we start deploying this technology to solve the truck unloading problem? And I'd like to tell you everybody about the journey we went through as a company in the past 6 years to get to a point where we can actually and confidently unload trucks. So one of the first systems we worked with, as you can see here in 2017, we published it. It is, we just put a robot on a linear stage. The linear stage can go in and out of the truck. We have put a gripper on it. At that point, we were using suction. So we have the top suction, the side suction for support. And we started, unloading trucks. You can see the vision system here, what that looks like. The robot will figure out, where the cases are, and it will unload. So this was done 6 years ago, and maybe some of you are looking at other systems today of companies trying to sell you the system. This is what it looks like when it works well. However, there are a lot of challenges to this. As you can see, one of the bigger challenges is the cycle time, right? You have to sort of grip the box, you have to transfer it. Maybe you don't know the right size of the box, and you get into a lot of challenges with this type of system, which became very clear to us as we did more R&D to develop it. One of the first challenges was the side suction gripper that we used. Unfortunately, and regardless of what popular belief is, you cannot pick up heavy boxes with just that side suction. And a lot of heavy boxes kept on dropping from it, right? Because if you're picking up from the corner, you can sort of think about how the physics works. You have the moment, which is like sort of like the box peels off very quickly. No matter how strong suction you get, you're going to have this problem. And our first vision system looks sort of like this. There was 4 3D sensors that are always taking snapshots of what's going on in the world. And basically, this is like an example of what that snapshot would look like. And you can see the robot is always in the field of view. There is, there is a real necessity for doing a fusion of all these sensors to get clean data. Right? So let's say we take the 4 snapshots of each sensor, and then when we compose the scene view, we get something like this, where we would actually figure out, okay, so this is what the full depth of what the inside of the truck looks like, and now we can go and start picking. And you can see even then there's some data missing in red of where there was the robot there, and then no sensor actually saw the data. So to summarize our first system, which we did back in 2017, the vision system was a fusion of 3D sensors. We used the side and top suction. And then going in and out of the truck, we did with motor-driven linear stage. However, there was a lot of problems with this. So next year, the year after that, in 2018, we built this system. And you can see here, the gripper is the major advancement. Right now we can actually start picking up heavy boxes because you have a supporting stage underneath. And it gets really interesting when you pick up a box from the bottom. You can sort of do this like tilting mechanism where you like would slide the tray underneath the box and you sort of tilt it and it will go and do the job for you. We're playing around with this for quite some time. It worked pretty well. The robot actually can do pretty advanced maneuvers because it is, after all, an arm, right? So the arm can go and maneuver into places which, usually is hard to do. The vision system itself, at that point, became a little bit more advanced in terms of the processing. So we would sort of figure out, where the edges are, where the bottom of the box is. That is really, really important to make sure that we don't really, mess up, where the bottom of the box is, because then, we won't be able to pick it up. And there's a lot of sensors in there to make sure that we don't cause an accident. It is very important when we're creating automation systems to keep in mind that an automation system only gives value to the end user when it's working and it doesn't require like somebody to always maintain it or somebody to always babysit it, because that is not an automation system. The truck variety also can get quite crazy very, very fast. Sometimes, maybe the tray is not enough, or maybe the box is deeper than you think, right? There's no way to measure depth in this particular scenario, right? So maybe the only way with this type of system to really understand the depth of the box is to sort of assume it's at max depth, but then you won't be able to like pull it out, right? Because it's max depth, or it just falls, right? Which is really bad for the customer. Right, so you can see, even with this type of system, there's still disadvantages to it. We're still not solving the full problem. Let me tell you, so just to summarize, what we changed here was just the gripper, tray conveyor, but we have all these other issues. But let me tell you now some of the major disadvantages that we saw after developing the second prototype. The first one that I believe was actually the killer one was the arm and gripper disadvantage. When you have an arm and a gripper, what happens is the arm, is trying to pick something up, but then it has to rotate, to get to the conveyor, right? So that's like 2 to 4 seconds there. And then it has to rotate back to get the next box. That's maybe a little bit faster because it's not holding anything anymore, so maybe 1.5 to 3 seconds. But altogether, you have about 3.5 to 7 seconds lost just on this one issue. Well, let me tell you what that means, guys. 7 seconds is around, if you think about in terms of throughput, that's like 5 cases an hour that you've just lost, right? And we're not even talking about the gripping and then all the other things that have to go on inside of the system. So usually, just because of the arm, these types of systems, the throughput is very low. And this is something we battled with as we try to sell our second prototype to the Japanese market at that moment. Everybody's like, well, it's great, Mujin, that you can go and do this great job of picking up boxes. You have a fancy demo. But you're 300 to 400 cases an hour. And at that point, I thought that was like even a crazy number to promise. Even then, the customer wouldn't go for it. They're like, no, it's not good enough. We're actually paying more for the truck being at our dock, right? And it now creates, a bottleneck, right? Because when the robot is in the truck, a human cannot be in the truck anymore. So throughput actually ended up killing that idea. Another thing is the sensors we were using at that time really weren't optimized for the type of distances and the type of scenarios for looking inside of the truck. You can actually see a use case here where, all the different sensors, when they come together, there's actually, discrepancies. It doesn't match them perfectly, right? It's just the nature of the way the system worked and also the quality of the sensors. You can see the edges are really, really poor. And all that affected, our quality of being able to determine, the mixed cases inside of the container measure them, and then pick them safely. Another thing is, what happens if we use a mobile manipulator, right? So linear stage, had its problems. And then we were considering for some time, well, let's put it on AGV. Actually, at that point, we had considered a forklift, right? So there will be like we had a company work with us to put a robot on a forklift, right? And then that forklift would like drive autonomously, go do its thing. The robot would be on it. And then it would be relying on battery power. Well, that's the problem, right? Because these robots consume a lot of energy. You're going to very, very quickly run out of battery power, right? So you're going to have to recharge it. Guess what? When your robot is recharging, it's not doing work anymore. So there goes half of your potential throughput. Or you can tie a cord to it, and then you're going to have to do cable management, right? Because it can get tied up. Maybe somebody steps on it. You guys have seen what production field looks like. There's forklift drivers running all around. If a forklift runs over your cable, that's it. Game over. So it's a pretty tricky problem in general. The other issue with mobile manipulators is navigation complexities. You have to have sensors now. LiDAR. Everybody uses that. Or nowadays it's like even 3D sensors. They put that everywhere. Make sure the robot doesn't bump anything. But at that point, you're relying a lot more on software, on sensors that might or might not give you the right data. And that's another point of failure. And the other issue is obviously the reduced speed due to stability. Unless you put like 10 tons on this, the robot cannot move full speed. It has to slow down. It has to consider the moments, right? The where not to tip, how fast things go. It has to consider, how much weight the box has, right? So that all of a sudden these become limitations now to your system. It's not actually solving the problem we wanted to solve anymore. So what's next, right? So we were stuck on this for quite some time. And at one point in time, we even stopped the R&D into truck unloading because we're like, well, it's a hard problem. This is what we came up with. It's actually that robot over there. So it's we strategically placed the robot so that when I do a presentation, you can go look at it there, make sure it's running, and I'm not just BSing you guys. But let me tell you a little bit about TruckBot. So one of the first challenges we did to solve was the vision problem. We developed our own 3D sensor specifically designed for truck unloading. And this is at 4 meters away, whatever that is in feet, 13, 14 feet. At 14 feet away, you can actually see how clean the edges are on like a flat surface. They're so clean, we don't need to do any AI anymore. That's it, we solved the AI problem by removing it from the equation. There's no AI here. There is just, find the 3D edges, and now we know the size of our boxes. Obviously, there's a lot of sensing technology that goes into that. But everybody, we can rely on that, right? That's just computation. That's physics. That's light. The second challenge we had to solve was the gripper. So this was interesting. We learned a lot from our side pick. We learned a lot from our tray conveyor. And in the end, we converged to this type of gripper here. So the gripper basically, has a bunch of cups. This is in slow motion actually, so you can see what it looks like. All you have to do is get the edge of the box onto the edge of the conveyor. That's it. And then your problem is solved. Then it will just suck it in. Right? And then the suction cups, there's like a really fine real-time control of like getting the suction cups right underneath so that they can go into the next pick, right? So just that one effort already is quite fast to grip something. But also we have so many sensors on this gripper. I don't even have enough time to tell you all the sensors on this gripper. We know the depth of the box, right? So we know how long to wait there to receive the box until it's like fully onto the gripper. And only when it's fully onto the gripper do we go and move to the next box, right? So you can imagine how this would work, right? All you have to do is swallow one box, and then the moment you get the edge of the box, the moment you see, okay, my whole box is on the gripper, let's go to the next box immediately, the one to the right of it, right? And then to the one to the right of it, and the one to the right of it, right? So this entire process, we can get down to 3 to 4 seconds, right? We just have to swallow and just move right. Swallow, move right. And that's what gets us to incredible speeds. We've even timed this guy up to like 1,000 cases an hour, right? Even faster than a human being, because we can exploit the structure of the problem. And we also failed many times trying to solve it. The third part of solving this problem is the mobility aspect, right? So we talked about, we had like a linear stage. We talked about mobile robots, autonomous forklifts, AGVs or AMRs, et cetera, et cetera. Here's what we ended up converging to. A telescopic conveyor. I know it's simple, right? It's like really dumb in some sense. But actually, all of these sites right now, all of these warehouses, import centers, whatnot, they all have, a lot of them have telescopic conveyors in there, right? Because it works. People know, they know how to install it, and it provides a really good base. And all it has to go is front and back, right? You don't have to worry about anything else, just front and back. There's no sensors there. There's no navigation. You don't have to go and worry about its failure cases. And it's a very solid product off the shelf. There's like 10 plus companies doing this right now in the world. It stretches out a lot, right? So this is like 60 plus feet that it can stretch out. So it can go and do your trailers, right? That are 53 feet long, no problem. And really the concept of TruckBot is you put it on the telescopic conveyor, right? It's like a retrofit. You just, whoever has telescopic conveyor, great, we'll give you TruckBot, and it will go and swallow your boxes. So the box would, here's sort of like the flow of the boxes on top of this guy. Let's see. People keep on calling that part the throat, I'm not, they were asking me like, what's the size of my throat? And just, it's a little bit too much, but that's where they go through. And then once they're on the telescopic conveyor, then you're home free home, right? You're just, at that point, it's singulated. You can do your scanning, barcode scanning or whatnot, and then put it into storage or build your pallets from that. The problem is solved. Here's what that looks like in action. So this is a mixed skew wall. The robot actually has no idea what the size of the skew is. And it just needs like one snapshot of the images at this point. And then immediately it knows how to pick things up, right? And the really cool thing is it will actually, you can actually see once it completes something, it will actually move forward so it can go to the next part of the wall. You'll see there's like a scanning section here. And then once the scan is done, it actually figures out at that point, roughly here's where my hypotheses are of where the box could potentially be. And once the robot grabs the box, at that point we know its exact dimensions, right? We know its height, we know its width, and we know its depth, right? And immediately, because we know that information, we can feed that into the next pick, and the next pick, and the next pick, until eventually there's no more picks left. So the processing time here almost insignificant in some sense. It's just likes to swallow boxes. That's what we do at Mujin. You can see the 3D sensors over there in the foreground. And there's the axis of motion. You probably noticed there's like a front axis here. So, we were sort of considering in the design process, well, do we have the telescopic conveyor move at the same time? Actually, that wasn't a good idea, just because we can't do real-time control of these like conveyor systems. So we have our own like linear axis that goes back and forth. And so the robot basically is doing a motion like it's attacking the box and then pushing back, attacking and then pushing back, right? And then it just keeps on doing that until it's done. And we've tested this on 50-pound boxes plus. So far, it works pretty well. And we don't have to worry about where the container is because it's just telescopic conveyor that's driving us forward. So here's what, just a little sneak peek of what the gripper can do. We actually, when we pick up the box at this instant, we take a snapshot of data and we're like, oh, okay, so this is what the width looks like, right? As you can see from this point, it looks pretty obvious. Yeah, you can measure everything at that point. Yeah, this is what we do at Mujin, and this is what the Mujin controller is capable of, doing crazy applications like this. But let me tell you a little bit about what's beyond truck unloading, right? Because that's only part of the inbound process. The other part is sorting this into single SKU pallets, right? And it turns out that 60 to 70% of your FTE effort is in this sorting process. So what people usually do is they have this like flexible conveyor, they put it around the line, and then they're just building, the pallets across the conveyor. Eventually those pallets gets built, and then they get shipped to the storage, right? But it's a very, very human-intensive labor at that point, even more than the truck unloading, right? Even more than the truck unloading. This is a much more intensive labor. So how do we automate that, right? We actually had, we have a project, in deployment right now, and this sort of gives you the idea. We have like this AGV system that you can see. It's on the left and right of the robot. And basically, the correct AGV will get called for the correct SKU because we have some look-ahead buffer. And based on that, we would go and create these single SKU pallets. And if we fill up a pallet too fast with a single SKU, well, we go to the other pallet. There's like 4 pallets around the robot. Sometimes things come out of order. And it's very, I don't think I showed this in this video, but we have this buffer, this like white thing behind the robot. So whenever we get something out of order, and let's say we have our 4 pallets, all full with different SKUs, maybe calling a SKU in and out, or a pallet in and out, takes too much time. Maybe it's gonna take like 30 seconds or a minute or something for the correct AGV to get called. Well, we're just gonna put it in the buffer until that the appropriate AGV comes, and from there we're palletizing from the buffer to the AGV. Right? So you can see how much technology has to be involved to solve this problem, right? This, it's not just a fixed scenario. Anything can happen in your production center. We have like sensors everywhere tracking exactly what's going on, making sure there's no accidents occurring. And whatever comes from the input conveyor, we have to go and handle that. And eventually the system it becomes so stable that these pallets that are right now being moved by AGVs directly go into your storage by another automated way, right? So by figuring out how to automate the truck unloading, it opens up possibilities to go and automate the next step, building the single SKU pallets. And from there, you just put it into an ASRS. So at Mujin, we do a lot of systems, and I think this is just a testament to the product we create, the Mujin controller. Anywhere from factory automation to logistics, pretty much every type of picking and logistics. If you guys are interested, our booth is right there. It's the orange booth. I hope it's hard to miss. Please stop by and have a conversation about whatever your warehouse needs are. We'd be happy to tell you. So with that, thank you guys.